Hi everyone, welcome back to my channel. In the previous video, we have completed exercise 9.4, and in this video, we are going to look into the solution to RD Sharma exercise problems of arithmetic progression chapter and exercise 9.5. Entire exercise 9.5 will be covered in this single video. Let us begin with our first problem of exercise 9.5, which says find the value of x for which 8x plus 4, 6x minus 2 and 2x plus 7 are going to be in AP. If these three terms are going to be in AP, then the common difference of these two terms are going to be same. When I say common difference, it is nothing but the value of second term minus first term or third term minus second term. These two values should be equal. Then only we can say these three terms are going to be in AP. Now the author is telling that these are going to be in these are already in AP. Therefore, those values should be equal. Let us consider the subtraction, that is d is equal to second term minus first term and another d I can calculate as third term minus second term. Here this is the second term, this is the first term, and this is the third term, this is the second term. When I simplify this, I've just opened the bracket here, that is 6x minus 2. This minus when I multiply inside, it will be minus 8x, plus into minus will be minus 4, equal sign as it is. 2x plus 7, I have just opened the bracket. When I take this minus sign into the bracket here, it will be minus 6x, minus into minus will be plus, and 2 as it is. Now, I will bring all the like terms one side, that is 6x minus 8x. This plus 2x will become minus 2x when I get it on the left side. Minus 6x will become plus 6x when I get it on the left side. Then this minus 2 I brought it here, that is plus 2. Minus 4 becomes plus 4. Plus 7 as it is, plus 2 as it is. When I further simplify, I'll be getting 6x minus 2x. 6x minus 8x will be minus 2x, minus minus 2x, that will be minus 4x, plus 6x will be plus 2x, is equal to 2 plus 4 plus 7 plus 2, that is nothing but 15. Therefore x value I will be getting as 15 by 2. Therefore if x value is going to be 15 by 2, then these terms are going to be in AP. Coming to the next question, which says if x plus 1, 3x and 4x plus 2 are in AP, then find the value of x. This question is similar to the previous question we just solved. Again, if these three terms are going to be in AP, then their common difference should be same. Therefore, what we can say, second term minus first term, that is 3x minus x plus 1 should be equal to 4x plus 2 minus second term, that is 3x we have considered here. When I go on simplifying this, 3x as it is, I am taking this minus sign into the bracket here, it will be minus x, plus in minus into plus will be minus 1 as it is, then equal sign as it is, 4x plus 2, I just opened the bracket here, minus 3x. Again I'll bring all the like terms one side, therefore 3x minus x will be 2x, and this is also 4x minus 3x will be 1x, that I have brought it here, that is minus x. Then 2 as it is here, and this minus 1 and I bring on the right side, it will be plus 1. Further simplifying this, 2x minus x will be x is equal to 2 plus 1 is 3. Therefore value of x is 3. Alternatively, if value of x is 3, then these three terms are going to fall in AP. Next question is question number 3. Show that a minus b whole square, a square plus b square and a plus b whole square are in AP. The concept of solving this type of problem is again going to remain same. We are just going to calculate the common difference between second and first term and third and second term, and if those common difference are going to be equal, then we'll prove that these three terms are going to form an AP. Here we have three terms given. If these three terms are in AP, then their common difference should be same. Let us consider the common difference between first two terms, that is a2 minus a1. Here a2 is a square plus b square, and second term, that first term, that is a minus b whole square. When I simplify this, a square plus b square I have kept as it is, minus, I'll expand this a minus b whole square. I have put it in the flower bracket, that is a square plus b square minus 2ab. When I open the bracket here, a plus b whole square I kept as it is, and when I take this minus sign into the bracket, it will be minus a square minus b square, minus into minus becomes plus 2ab. Here a square plus b square and this a square minus a square minus b square get cancelled. Therefore, d will be 2ab. I'll keep it as first result. Now I'll consider the difference between third term and the second term. That is d equal to, third term is a plus b whole square minus second term is a square plus b square. A plus b whole square, I'll put it in flower bracket, that is a square plus b square plus 2ab. We know this expansion. Then minus a square plus b square, I have kept it in the bracket. Now when I open this bracket, a square plus b square plus 2ab minus a square and plus into minus, it will be minus b square here. Again here plus a square minus a square get cancelled, plus b square minus b square get cancelled. Therefore, common difference of third and second term is also going to be equal to 2ab. When I compare these two results, you can see the common difference is going to be same, that is 2ab. Therefore, what we can say is common difference of this AP is going to be equal to 2ab, and therefore these three terms are in AP. Next question, question number 4, which says the sum of three terms of an AP is 21 and the product of the first and the third term exceeds the second term by 6. Find the three terms. Here question looks a bit complicated, but it is quite simple. But we just need to make sure that we are writing down all the given statements in proper manner, so that this entire question can be broken into 2 or 3 parts, and we are going to analyze the question. Let us see how we can do that. The given statement says there are three consecutive terms of an AP whose sum is 21. Let those three consecutive terms be x, y and z. So remember, if three terms are in AP, then first term will be, if these three terms are in AP, then if I want to get the one term which is previous to the y, so I need to just subtract d from that, and if I add a d, I'll get the next term. So what I'll do is I'll keep y as my reference term, and I will consider the previous term as x and next term as z. So if I want to get x, I have to subtract just common difference d from the reference term, that is middle term, and if I want to get the next term, that is z, I just need to add the common difference d to my reference term, that is nothing but y. Therefore x will be y minus d, y will be as it is, and z will be y plus d. Accordingly, if these three terms can be represented as y minus d, y and y plus d. Now coming to our question, the first statement says sum of three terms of an AP is 21, which means when I add these three terms, it is going to be give me 21. Therefore, y minus d plus y plus d. These three terms when I add, I am getting 21. This is the first statement given in the question. Second question, what he say? Second statement, what he is telling is the product is nothing but multiplication. You can see here of first and third term. Product of first and third term. This is first term. This is third term. Product of these two terms exceeds. I have told earlier in my videos. Exceeds means we have to add. That is plus. The second term. It exceeds what? It exceeds second term by second term is how much? Our second term is y. It exceeds second term by 6. So we have formed those two statements from this given question. Now we'll just go on simplifying these two statements and we'll get some answer. Simplifying the first equation here, what I'll do is I'll just open the bracket, that is y minus d plus as it is, y as it is, plus as it is, y plus d. When I solve this, I get, you can see here minus d and plus d get cancelled and only 3y is going to remain here. Therefore 3y is equal to 21, or I can say y is equal to 7. Now what I got? I got the middle term, that is y as 7. Now if I want to get the previous term, I need to find common difference. If I subtract common difference from this 7, I'll get the previous term. If I add common difference d to this 7, I'll get the next term. Let us see how we can do that. For that, we'll start simplifying equation 2. What I'll do is I'll consider this product, that is y minus d into y plus d. We know a result of a plus b into a minus b, that is nothing but a square minus b square. That I will consider here, that is nothing but y square minus d square. That is equal to how much? Y plus 6. I have kept it as it is. Further simplifying this, substituting the value of 7, we just found that y is equal to 7 here. This value I will be substituting here. Therefore, in place of y, wherever y is there, I will substitute 7. 7 square minus d square is equal to 7 plus 6, or 49 minus d square is equal to 30, or I can say I'll bring 13 on left side and I'll take d square on the right side. Therefore 49 minus 13 is equal to d square, or 36 is equal to d square. When I take the square root of this 36, it will be 6. Therefore what I can do is the previous term, that is this term x is equal to, I need to just subtract d from y, that is 7 minus 6 equal to 1, and we know that middle term y is 7, and next term, that is z equal to, I just need to add common difference d to this, y plus d is equal to, that is 7 plus 6 is equal to 13. Now you can verify whether our answer is going to be correct or not. If I add these three terms, you can see here 13 plus 7 is 20, plus 1 is 21. Sum of these three terms is 21. So we have verified the first statement. Second statement is first and third term product. Product of first and third term, that is 13 into 1 is 13. It exceeds second term by 6. Second term is 7. If I add 6 to this, that is 13. Therefore, second statement is also verified. Therefore, those three terms which are present in AP are 1, 7 and 13. Next question is question number 5. Three numbers are in AP. If the sum of these three numbers is 27 and product is 648, find the numbers. Again, this is exactly same question as the previous question. In this question, just second statement is changed. That is, here he is just telling that product of those three numbers is going to give 648. Let us note on the given data. Just like the previous problem, I'll consider these three consecutive terms of AP as x, y, z, and we already know x can be represented as y minus d and z can be represented as y plus d. Here one thing you can notice is I'm just representing all the terms in terms of y only, so that it is going to become easy for us to solve. These three terms can be represented as y minus d, y and y plus d. Then as per the given statement, sum of these three terms is going to give me 27 and product of these three terms is going to give me 648. Solving one by one, first I'll consider the first equation. Therefore, here you can see minus d and plus d get cancelled. Again, therefore, I'll be getting 3y is equal to 27 and therefore y will be equal to 9. Now considering the second statement and simplifying it, I'll substitute the value of y in this equation. You can see here, before substitution what I'll do is I'll consider these two terms, y minus d and y plus d. We already know the result of a minus b into a plus b, that is nothing but a square minus b square, y square minus d square into this y I am going to keep as it is. This y will be multiplied to this result, that is going to give me equal to 648. Now I'll substitute y is equal to 9 in this. Therefore, I'll be getting y square minus d square, that is 9 square minus d square is equal to this y. When I take it on the right side, it will come in the denominator. Therefore, 9 square is 81 minus d square as it is, and 648 divided by 9 is going to give me 72. When I simplify this, I'll take 72 on the left side and d square on the right side. Therefore, 81 minus 92 will give me d square. this is 9 is equal to d square. When I take the square root of 9, it is going to give me answer as 3. Therefore x is nothing but y minus d, that will give me 6, and y we know that is 9, and z is equal to y plus d, that is nothing but 9 plus 3 is equal to 12. Let us verify if we have calculated these three values correctly or not. Sum of these three terms is going to give me 12 plus 9 is 21 plus 6 is 27. So first statement is verified. Coming to the second statement, 12 into 9 is 108. 108 into 6 will give me 648. Therefore these two statements are verified. Therefore those three terms are going to be 6, 9 and 12. Coming to the next question, question number 6, which says find the four numbers in AP whose sum is 50 and in which the greatest number is 4 times the least number. Even this question is similar to the previous two questions that we just solved. Just one more term is added, that four numbers. That is, we have to take the sum of four numbers, and second statement is little bit modified here. Let us see how we can solve this. Concept is going to again remain same. Here I'll consider four consecutive terms instead of three. Earlier we have considered x, y and z only. Now I'll consider one more term previous to x term, that is w. Now we know that x can be represented as in terms of y, that as y minus d, and z as y plus d. Now if I want to calculate one more term which is previous to term x, I'll just need to subtract one more d from this, because any term previous to any term will be that term minus common difference. Therefore if I want to find previous term to x, that is w term, I need to subtract d from x term, and my x term is nothing but y minus d. Therefore if I subtract d from y minus d, I'll get w term, that is y minus d will be y minus 2d. Hope you understood this, how we got w equal to y minus 2d. Now these four terms can be represented as y minus 2d, y minus d, y and y plus d. Now let us represent the statements given in the question in the form of equations. That is, first statement says sum of these four numbers will give me 50. That is, I'll just add all these numbers, which is going to give me equal to 40. And second statement is greatest number is 4 times the least number. In these four terms, we can see that y plus d will be the greatest number, because for in y I am adding something, and in these terms I am subtracting. Whenever I am adding, I'll be getting higher values. Whenever I am subtracting, getting lower values. Therefore this will be the least number, because I will subtract 2 times of d from y, and here I am adding one d to y. Therefore according to the given statement, y plus d will be 4 times of least number. Least number is y minus 2d. Now we'll just simplify these two equations and we'll try to get those four numbers. Let us see how we can do that. First, simplifying equation 1. Here just I am opening the bracket and trying to simplify as much as possible. Here 4 y's are there. I'll just write 4y minus 2d minus d plus d. This plus d minus d get cancelled. Minus 2d remains as it is, and equal to 50. This is going to I'm going to represent this as equation number 3, because again there are two unknowns in this. I cannot directly find value of y or d. So as you know from pair of linear equations chapter, if I have two variables, I'll need at least two equations to solve these two variables. So we need to form one more equation that we'll be doing using this second statement. Simplifying second statement, y plus d is equal to 4 into y minus 2d. I'll just simplify this. Y plus d is equal to, I'll multiply this 4 inside the bracket, that will be 4y minus 8 into d. Bringing all the terms to the left side, y minus 4y plus d as it is, and minus 8 will become plus 8, that is equal to 0 here. Now y minus 4y is minus 3y plus 8 plus d plus 8d is nothing but plus 9d. I'll just interchange the signs here, and or I can also tell as I'll multiply by -1 throughout because I'm not comfortable with this minus sign. Therefore, what I'll do, I'll multiply the with this equation, whole equation, with -1. So -1 into -3y will be +3y. Plus 90 into -1 is -90, equal to 0 into any number is 0. So I got one more equation here that I'll represent as equation number 4. Now I have two unknowns and two equations. Y and d are my unknowns, and this is my first equation, this is my second equation, which contain those two variables. Now using these two equations I can find the value of y and d. So I need to subtract. You know already that if you want to solve two equations by subtraction method, or by simplifying one of the method from pair of linear equation, that is subtraction, you need to have coefficients equal. So here you can see coefficient of y is 4 and here coefficient of y is 3, which is not equal. Again here coefficient of d is -2 and here coefficient of d is -9. So what I'll do is, in order to make coefficient of any one term equal, I'll multiply one term by coefficient of another term and I'll just subtract. What I'll do is, I'll consider the first equation and I'll multiply this equation by 3. Consider the second equation, I'll multiply second equation by 4. By doing this, what I will be doing, 4 into 3, that is 12y I will be getting, and here also 3y into 4 I will be getting 12y. When I subtract second 12y with first 12y, this y term will get cancelled and I'll be left with only d here. That is why what I'll be doing is multiply 3 with first equation and multiply 4 with second equation. Now you may ask, if we multiply and we are modifying this equation further by not equal terms, will it change any value? No, it will not change any value, because we are multiplying with 3 throughout this equation, means on left side as well as right side. Whenever I do equal operation on both left side and right side to a particular equation, value of that equation will not change. So I am multiplying 3 to this equation on both sides and multiplying 4 to this equation on both sides. I am just making this adjustment in order to cancel one term from these two equations. When I do this, 4y minus 2d into 50, when I multiply this by 3, it will be 12y minus 6d equal to 50 into 3 is 150. And similarly, second equation, when I multiply by 4, I will be getting minus sign because I am subtracting 4 from 3. I will keep it outside the bracket. 4 into 3 is 12y minus, I am keeping brackets inside the brackets, so I am keeping it as it is. 4 into 9 is 36d equal to 0 into 4 is again 0. Now I'll open the bracket because of this minus sign. Plus y minus y get cancelled. 6d minus, this minus into minus will be plus. So 6 minus 6d plus 36d will be 30d, which is equal to 150, or d is equal to 150 divided by 30, or I am getting d as 5 here. Now substituting this d is equal to 5 in equation 3 here. I have equation 3. I can substitute this d in equation 3 or equation 4 in order to find one more unknown term. I'll consider equation 3. I'll put d equal to 5 in equation 3. Therefore, I'll be getting 4y equal to 50. I am taking this minus 2d on right side. That will be 50 plus 2d. Therefore, 4y is equal to 50 plus 2 into, in place of d, I'll substitute 5 here. Therefore, 4y is equal to 50 plus 5 into 2 is 10, that is 60. Therefore, y is equal to, when I take this 4 below 60, it will be 60 by 4. Therefore, y is equal to 15 here. Now, calculating these four terms as equation given here, w will be y minus 2d. Y is 15 minus 2 into d, that is 2 into 5. Therefore, I'll be getting w as 5. X is nothing but y minus d, that is 15 minus 5 is equal to 10. And y term we have directly got, that is 15. And z term is 15 plus d, that is y plus d. So my y is 15 and d is 5. 15 plus 5 is going to give me 20. Therefore, those four terms are nothing but 5, 10, 15 and 20. Now, verifying this equation, if we are going to get the answer correctly or not, when I add all those four terms, I should be getting 50. So let us see if we can get that or not. 5 plus 10, that is 15. 15 plus one more 15 here, that is 30. 30 plus 20 is 50. I am getting 50 as per the first statement. Now let us see. Second statement says greatest term is 4 times the least term. Greatest term is 20, least term is 5. Isn't our greatest term 20? 4 times the least term, that is 5. 5 into 4 is 20. Therefore, we have found these 4 terms. Now with this we are going to end exercise 5.9.5. Hope you enjoyed the session, and I'll come up with next video taking exercise 9.6. It is going to be a big exercise, so I'll be breaking it into parts as we did for exercise 9.4. Hope you enjoyed the video. Have a and happy Diwali.